Hi, in this lesson we're going to look at similar triangles and postulates. Remember yesterday we said that similar figures have to have 3 congruent angles and 3 proportional sides in order to be considered similar. Just like when we did congruent triangles, we found shortcuts so we didn't have to show all 3 angles were congruent and all 3 sides were congruent to say our triangles were congruent. We do the same thing with similarities. And so we have some theorems or postulates that we use to prove 2 triangles are similar without having to show all the angles are congruent or all the sides are proportional. The first one is called the AA similarity, and it stands for angle-angle. If I have 2 angles of one triangle and they are congruent to 2 angles of another triangle, then I can say my triangles are similar. So for example, in this one I can see that angle A has a single arc on it, and so does angle D. Angle B has a single arc on, or double arc on it, and so does angle F. So that tells me that these 2 triangles are similar. It's not enough to prove that they would be congruent, but they are definitely going to be similar. So triangle, if I name the first one ABC, then just like when we're using a similarity or congruent statement, we have to do the same thing as looking at the order when we use a similarity statement. So again, I'm going to start with triangle. If I started at A that has the single arc on it, then I need to start at D with the single arc on it. From A, the second letter was B with the double arc, so that means I'm going to go with F, and then end up at E. So DFE. Triangle ABC is similar to triangle DFE. Okay? The next one is my side-side-side similarity, and it says the measures of corresponding side lengths of 2 triangles are proportional. So not congruent, because remember if we're doing congruent, then we're going to congruent triangles, and here we have similar triangles. So when we say proportional, that means when I create the ratios of the corresponding sides. So D to T, and then A to Q, and then B to R, all of those fractions, all of those ratios would equal the same thing, which would be the scale factor between the 2 similar triangles. So again, if I start with this triangle and I say triangle ABD, that would be similar to, and sometimes with this one we can kind of see they're sitting in the same spot, but if you can't see if they're rotated around or different, when you have the actual numbers here and you can test to see if they're proportional, you'll just make sure where your small, medium, and large sides are, and that's how you can line up those corners. But in this case, ABD will be similar to QRT. Make sure you're using capital letters because they are the vertices of the triangles, and make sure you're using your triangle symbol in front. Okay? And then there's only one more. So we had 5 when we did congruent triangles. There's only 3 for similar triangles. My third one is the side angle side similarity. Okay, and that is the measure of 2 side lengths of one triangle are proportional, so you're going to do your fractions, to the measures of 2 corresponding side lengths of another triangle, and the included angle is congruent. Okay, so I can see here I have this included angle, and it's included between the 2 sides that make up that angle. So here HK and HJ, and then here DE and DF. Okay, so I can see it's the included angle. It's where these 2 sides that I have marked come together. Okay, so my first triangle, I might call it triangle DEF. And it's going to be congruent, or sorry, similar to triangle DEF will match with HKJ. Triangle HKJ. And again, remember capital letters and my triangle symbol in front. So just as kind of a little reminder, with my 2 angles, it's just they're going to be, the angles are going to be congruent. Okay, so congruent angles, 2 congruent angles, we should remind ourselves, 2 congruent angles, and you have the angle-angle similarity. Okay, on the next one, my corresponding sides are proportional for side, side, side. And then the last one, it's going to be 2 sides are proportional and the included angle is congruent. Okay? All right, so let's look at some examples. Determine whether the triangles are similar. So when I look at the first one, I'm going to pick one of the 3 theorems or postulates to test. So when I look at this one, I don't have any angles marked. So I'm not going to be able to use angle, angle, or side, angle, side, but I do have all 3 sides of each triangle. So what we want to do is check to see if they are proportional. We're going to test side, side, side. I don't know if it works or not yet, but that's what we're going to test. Okay? So when I test it, we want to make sure that we line up the corresponding parts. So my short side from one triangle has to match up with my short side from another triangle. And then my long side has to match up with my long side, and my medium has to match up with my medium. So sometimes what I'll do is I'll label my small side and my large side on each triangle. 9 is the smallest number, and 15 is the largest number. And then I just know the 8 and the 12 are my mediums. And we make sure that we line everything up. And again, I will oftentimes put arrows in my triangle so I remember which one is always going to be in the numerator, which one's always going to be in the denominator. So I'm going to do small to small, up arrow small to down arrow small, 6 to 9. And then I'm going to do my mediums that I didn't label, 8 to 12. And then I'm going to do my large, 10 to 15. And these are proportional if these 3 fractions are equal. So 6 and 9 are both divisible by 3. 3 goes into 6 2 times. 3 goes into 9 3 times. 8 and 12 are both divisible by 4. 4 goes into 8 2 times. 4 goes into 12 3 times. So far so good, those are equal. And then 5 goes into 10 and 15. 5 goes into 10 2 times, and 5 goes into 15 3 times. So it says determine whether the triangles are similar. My answer is yes. They are similar by the side, side, side postulate. Okay? If it asks me what my scale factor is from this triangle to this triangle, then my scale factor is 2/3. If I want my scale factor of the big triangle to the small triangle, then it would be 3/2, right? Because it would flip over. Okay? All right, let's look at this next example. In my next example, I have an angle that I can already see is congruent, but I only have the one angle here, angle R and angle N are both 70. And then do I have the sides that include that angle? So I've got a 3 on one, and I've got a 6 on the other. And then here when I come out of R, I have a 4, and when I come out of R, I have an 8. So I can test side, angle, side. I already have the angle. I have to check, are the 2 sides proportional? And I'm going to do the same thing, labeling the small and the large, just like I did on the last one. So my small is the 3, and my large is the 6. Here, my small is the 4, and my large is the 8. Oops, large. Okay? All right, so when I look at this one, and if I were just trying to assume whether or not they are similar, I might say yes. And then if I was asked to do the scale factor, a lot of times people go, okay, 3 to 6, so the scale factor here is 1/2. But remember, when you're doing scale factor, you always need 1 from one triangle and 1 from the other. Okay, so you really do want to do the proportions to get your scale factor. All right, so I'm going to compare small to small, and I'm going to put my up arrow in the first triangle and my down arrow in the second triangle so I stay consistent. So I'm going to do small to small, so 3 to 4. And does that equal large to large? Up arrow 6 to 8. 3/4 does not reduce, it stays 3/4. And 6 to 8, 2 goes into 6 3 times. And 2 goes into 8 4 times, so these are both equal to 3/4. So my scale factor here, even though it's tempting to go, my scale factor is 1/2, right? Or 2, because I have to multiply by 2 to get to that side. It's tempting to say my scale factor is 1/2 or 2, but it's not. Here it's 3 to 4 if I'm doing the left triangle to the right triangle. Okay? But it didn't ask me for a scale factor. It just wanted to know, are they similar? My answer again is yes. Okay? All right, in the next video, we're going to do a few more examples just like this one. Thank you for watching.